It's like a missile launch, isn't it? Oh.
All right, we're live now. We're streaming.
Okay. Good afternoon. This is the November meeting of the Chicago TI Users Group. Welcome to Chicagoland. Today we have an excellent show for you, we think. We have a number of programs to be demonstrated by Vic Stirp, our president, and we have a couple of videos. First of all, let me introduce everyone who's here. I'm Hal Shanafield. I'm the fair chairman, obviously the guy who's doing this introduction. And our president, Vic Stirp, is also here. He'll be doing the demonstrations of all the TI programs. Jim Mazurek, our technical guru, is standing by and organizing this meeting on Google Meetups. That's going to be broadcast on YouTube. And our YouTube engineer is John Shanafield, who's putting this whole show on the air for you. To begin, Vic is going to do some programs, some game programs, I believe. And then after that, we're going to have a couple of videos which were originally created for the fair, but were unfortunately received too late to be included in the fair presentation. One is by Ronald Van Kloinen. Another is by Klaus Lukaszek. The first one is kind of short. The second one is a lot longer. So please stay tuned and watch both of those videos as well. Now, if you'd like to communicate with us, there are three different ways to do it. The first is obviously the chat function on YouTube. The second is the comments section on YouTube. And the third is to contact us directly at Yalmar2, which is my screen name, on Skype. I'll have that on, and if anyone wishes to call in, ask a question or make a comment, they can do so, and I'll take that directly. So without further ado, let's get right to our president, Vic Stirp, and the programs that he's going to demo. Vic, take it away.
Thanks, Hal. Am I coming in okay? All right. I'm lucky enough to have a Finalgram 99 and a compact flash sidecar set up. So this makes traveling with the TI a lot easier. This past week, I was over out of state at my daughter's house because she was between nannies. And so I brought my TI and I played games with my 5-year-old step-granddaughter. And I've never played so many games of amazing in my life. Let me get my notes here, and I'll get the first thing loaded up here. All right, so here's the main menu on the Finalgram, and I have many libraries that I've collected over the years of bin files. One was as early as 2015 from Mr. Bittori, who had a collection of files from emulators. And then Barry Harmson has these next four, card C, G-2, G-3, G-4. Mike Lunsford, when I got the Finalgram, he had demo files on it. The F demo in TI mode and demo in F18 mode. I set up device and education and then games A to M and a whole bunch of other stuff. But we'll go to Bittori here. And we're going to select letter D, educate. Page 2 of 5. Nope. You have to go back one. A, B, C, D to educate. There we go. And in the upper right corner, you'll see the menu flicker. This is page 1 of page 5. And I can advance to page 2, page 3, or I can go back one. And we're going to select I for, there's a rather cryptic name of Great W ... one, because that's a folder. So we'll select I, and here shows the actual program, the Great Word Race. This is a fun game for juveniles. And we'll start with training. And why am I not hearing music? Hello. Okay, I'm showing audio on this end. Okay, I'm showing modulation here on my screen. Is it coming through? This next word.
CI.
I don't know if you're hearing the music on this game. So you pick up the letter B, carry it back to the home and top, and it drops off the letter so there's all on this. Programming through. Go back to the TI title screen. Go to the Great Word Race. Then we're going to go to a higher level here, like B for beginner. It's sort of funny how the these. This one we have a little crawly creature. And to touch my character, I lost it. Now we got crawly creatures. The word still shows up on the screen as to what the well, now there's three creatures. Well, what I'm supposed to do in this case. Yeah, so for you Pac-Man fans, pretty darn quick. We're still on three-letter words, but we got these pesky monsters chasing us around. But it's possible to win that level. So I'm going to quit it again. Reload it. Go to intermediate. We're up to a four-letter word. Look at the platforms that you have to negotiate. Reload it. We're going to select number 4, advanced. You have a 5-letter word and difficult platforms and ladders and such to try to negotiate. Quit it again. Go to 5 for expert. You know, we never start demonstration with expert. Notice they didn't even tell you the word. You have to look at those letters and figure out what the word is on expert. Quit it again, reload it. So that was the great word race. Now I had noticed there was another program that looked awful similar in a different location here. One moment, let me get it. We're going to go to the J for games, A to M. Select the page. We're on page 1, page 2, page 3, page 4 of 7. And we're going to select option F here, F for face-to-face. It's a lot familiar. This is for persons who perhaps don't know how to spell yet. So they can pick the word play the same way. Press the fire button when your character is on a letter, and that was a smiley face. This might be for kids that haven't even quite learned how to speak. You can just pick up these faces in any order, and you're a winner. This is the first level. Yeah, if you miss the letter and you press the fire button on something that's not the letter, you get that sparkly thing there on the ladder. So we have pilot, town, face. And then reload the cartridge. Press the key. Now we'll see what beginner is like. Okay. Beginner looks awful similar. We got that little alligator creatures that are running around trying to get us. Apparently they're fat. Video magic. Oh yeah, this was designed by our old friend John Phillips, who actually made it to one of our meetings at the library a few years ago, and we learned a lot from him. Go to number 3. Okay, they got the broken ladder. At least you don't have to pick the letters up in sequence. Put it again. The cartridge. There might be a way of going back to the title screen and then I don't know how it is. Go to number 4, advanced. It starts off with 2 updates, right? Reload the game. That's fine. 5 for expert. And you can see the letters are in an even more complicated pattern. I count 5 monsters on the screen. Quit the game. Go back. Let's see what Pro is. We didn't go up to Pro on the actual word one. All right. More complicated. Oh, let's go all the way to Wizard. All right. So this is the Wizard screen. It starts out with 5 monsters. And I see you have to go all the way over to the lower left here and get on this ladder to be able to pick up anything that's on all these ladders, like the one in the middle of the screen near the bottom. So that was Face Case. I'm going to reset the final gram. And load up RXB. Go to directory. Oops, got to go to caps again. Had to leave the cap locks up. Okay, this is from the Tiger Cub disc, 751. And here's one of our old favorites, Ernie and Bert. The unusual thing about this is not that the Sesame Street characters Bert and Ernie talk, but it's how they do it. They're not using the built-in generation of words in the TI speech synthesizer.
Well, I was wondering if you would pretend that you're angry for me. I pretend I'm angry for you. Hmm? You see, I was just, because you're really just great at getting angry.
Then it repeats with the words on the screen.
Hey, Bert. Yeah. See, I was wondering if you could do me a big favor. Sure, what is it? Well, I was wondering if you would pretend that you're angry for me. I pretend I'm angry for you. Hmm? You see, I was just, because you're really just great.
Program will loop forever. It's an extended basic program. It's not basic with the terminal emulator cartridge. So we'll list this. And when Jim Peterson distributed this in Tiger Cub, he had this note: the source of this program is unknown. If anyone knows its origin, please send information to Barry Traver. Must have discovered this program and forwarded it to Jim Peterson, who put it on his Fairway library site. So Barry says he's modified the program to eliminate the need for an external data file. So we'll go through the character setups, the draw Bert and draw Ernie, draw the bricks, call sprite, call hchar, call hchar, call sprite. Funny that they use sprites for to finding them talking. So we're going to get up to it real quick here. Just bear with me a moment. Yeah, this is the part where it actually displays on the screen what they're saying. Okay, here we get into the meeting, line 8030, call say. And then we get into the actual data of what they're seeing. Okay, here we are at 9,000, this data sheet right here, to where, oops, I just bumped my camera. That is not something really type into the TI. Actually, if you try to print this out, you will get numbers that wind up as some printer codes, and your printer will go nuts if you try to print this out. However, each data statement there is a different sentence or a different group of words, different phrase. And so I have played around with this, renumbering these data statements and putting them out of sequence, and sort of did identify which statement was which phrase. So someone had digitized the speech off of Sesame Street and somehow ported it over to our TI. So that's just for fun. For the next one in our speech demo here, I'm going to clear the computer, reset the final gram, and I'm going to load the terminal emulator cartridge. So in my set of files here, that's letter Q for tools. We're on page 1 of 3. Go to page 2 of 3, 3 of 3. We're going to select letter D, terminal emulator 2. But we're not going to use terminal emulator. We're going to select TI Basic. And moment here. Okay. It would help if I was a little more prepared here. I'm going to go back to the reset the final gram. Too quick on the draw. Okay. We're going to go to page 2. We're going to load RXB and press the period for editor assembler and D for directory. Select disk 1, and we'll do a catalog of disk 1. Okay, so I'm looking for is not on disk 1. It's on disk 2 of the Nano PEP. And here it is. Okay, in this, these are all children's speech programs for the TI. And stuff like in alphabetical order, AlphaSing, Bolin, Ernie and Bert, and Croakers, and Liftoff are all extended basic programs that load off this load program. Everything else that you see here that ends with BTS is basic and the terminal emulator cartridge with speech. That's the diagonal and the BTS means. So I have to actually bear with me a moment. I actually have to write down what some of these names are. Like our jokes is the robot jokes that we had on the CTIUG website. Okay. All right, I got that. We're going to quit this. It's usually not running extended basic. Go back to Finalgram. Go back to Q for tools. Go back to page 3. Press letter D for terminal emulator. Get terminal emulator 2 loaded. Quit. Go back to title screen. Select 1 for TI Basic. Okay, now I know what program I want to run. Old disk 2. No, that's not what I want. Okay, nano lights are blinking as it's loading from the virtual disk. Initializing. And we'll run. Screen turns green.
I am Rocky Robot. I am Rocky's twin. We will tell you 46 robot jokes if you don't hurry and turn us off. You see, we are kind of sick ourselves. What animal rolls down instead of up? A goose. Where do good little engines wash themselves? What do you give to an old lady just passing 65? A traffic ticket. It's the second day of the week, pronounced Tuesday or Tuesday. Neither because it's Monday. Did you put an ad in the paper for your lost dog? No, he can't read. Why doesn't a bicycle go as fast as a car? It's too tired. How are dog catchers paid? By the pound. What does it mean if you go home and you don't have to do homework, wash your neck or clean your room? It means you're in the wrong house. Why was the cow going to a therapist? He had a father complex. If athletes have athlete's foot, what do astronauts have? Missile toes.
Okay, well, we did run that video on the Chicago User Group Facebook page in its entirety. John, are you about ready to queue up any of our other videos?
Yeah, I can get them ready.
Okay. Well, I've had fun running these demonstrations. I mean, you saw the great word race and followed by its sister, Face Chase, for youngsters. Then we had the speech with Ernie and Bert with digitized speech on the TI. TI did do digitized speech on like Alpiner. I think the most famous one is Parsec, where they had the refueling tunnel and the asteroid belts. The navigator would warn you of hazards. So yeah, the TI does have some digitized speech. And this last demonstration of robot jokes by Sam Moore Jr. Was pure TI speech, basic with the Terminal Emulator 2 cartridge and the speech synthesizer.
Okay, Vic, you ready for the videos?
Yeah, go ahead, broadcast the videos.
All right, here they come.
In this video, I'm going to show you how to transfer files from a PC to the CTIUG Geneva 9640. Now, therefore, I'm using the program of Fred Kahl, which is the TI99HDX 9.1a, which you can download off his website, which is ti99-geek.nl. So this program is connected to a COM port, so that means an USB to RS-232 interface, and then again to the RS-232 card in the Geneva box. Now on my PC I have here directories with different files for the CTIUG. You see here, for example, files, and you see all the files over here. And the reason I'm doing this is because in the CTIUG I have an Horizon RAM disk, and also two floppy disk drives, a 5.1 quarter and a 3.5. But I don't want to transfer every time to a floppy disk. So with a serial connection, I hope it makes it easier to transfer files to the Geneva. So now we go to the Geneva, which is located over here. So it's all installed in this box. So here you see all the different cards. All right, and turn it on. So it boots the system from the Horizon RAM disk. All right, so we type GPL to go to the TI mode. All right, now we want to load the editor assembler, and this is actually a combined cartridge. So disk 8.xb directory, and then xbea. All right, so now we press enter. We loaded the cartridge actually in the module slot. So we're now in the TI mode, and we have two modules, TI Extended Basic and Editor Assembler. So we go to Editor Assembler, we go to option 5, and we load another program, which is already on the Horizon hard disk. It's called CFHDXS1, also of Fred Kahl, which will communicate to the HDX1 server on the PC via the serial interface. Okay, so it's now started. So ignore all the letters over here, because I think my program is corrupt. But if I go to the source, I enter HDX1, the dot, and it is now reading all the informations of the PC. So again, if I go to the files directory, it is retrieving all the different files here. So for example, if I want to copy a program, like I think this is an XB program, I enter plus, proceed, copy, and now I need to enter the destination. So I say DXK 8. And it was copying it to disk 8. So let's go back. So the program was called muurklim, climbing a wall, it means in Dutch. So let's exit here. Go to extended basic. Now it tries to load from disk 1, but there's no floppy drive, no floppy disk inside. I'm back into the ready mode. I do alt disk 8 dot muurklim. It loads the program, and here it is. Let's run the program. Right, so cancel the program. Oh, it doesn't work. So to go back, we should press Ctrl-Shift-Shift. Let's see if that works. Okay, so Ctrl-Shift-Shift brings me back into this mode. So now let's go outside the TPL and we're back in the Mayark mode. And if I do a directory, then if everything is okay, I will see here the program muurklim. Now we had some directories, so like for example the XB directory. So with the CFHDX tool, you can also send it directly into the directory. Now let's go back to the PC. This is over here. So now you will see that in the HDX program, you will see all this kind of communication with find place. So we can actually scroll back a little bit. Hope it is sharp enough to go all the way back to the top. So here you saw the initialization procedure, and that is actually when the CFHDX1 S1 tool starts. And then you can browse to the directories and you see that all this communication finds place. Now the speed is satisfying over RS-232. It's actually much more faster than I copy first everything to my TI and then to my floppy disk and to get it onto the Geneva. So on my TI I have a TP, and then I can send it over Wi-Fi from the PC to the TI-99/4A and then copy it to a floppy disk. So you see the procedure takes very long compared of copying it via an RS-232 interface in this manner. So thank you for watching and hope it is useful for you.
So, yeah, there are more or less there's this TI extended basic topic I want to talk about. Everybody will know the cartridge as such for the TI-99 to plug it in and have programming abilities beyond TI basic, what is within the cartridge within the console directly. So this cartridge features 2 ROM chips. And they are bank switching, so we are considering in total 16 kilobytes of assembly memory in the cartridge space, and depending on which bank is active, then the other bank is showing in this cartridge space. But there is one part of the bank equal among both banks, so it's not a full 16K, not the full 16K is used, otherwise you would not have any references in the second bank towards the first bank, so we could not switch back or whatever. So part of the code is in both banks, to say it short. Then there is also GROM chips on that. I think it's 4 GROM chips in addition to the console GROMs. that extend basically and make this the TI, the very famous and known TI extended basic. What might not be so known is that actually the community scene has got its access to the has got somehow access to the source code of these files. So we're not talking about the TI extended basic manual for the users who want to start programming. No, we're talking about the source code of this module. So how this computer language was developed and is happening. So why it has the call sprite or why it has the display add command in addition to whatever is in TI basic. So basically the source code, the lines that define TI extended basic. So there is RXB or Rich Gilbertson, I hope I pronounce it correctly, from America, who once bought 2 manuals. It was sold like manuals about TI extended basic and GPL. And the books were from some TI employee origin, so some internal documents. And actually, those books revealed as the printouts of the source code. One book, as far as I remember, it was the printout of all the assembler files. So all that ends up in these 2 ROM chips. And the other book was basically containing all the source code outputs, the printed outputs of the 4 GROM banks. So, and those included GPL code. So in addition to assembly language, the Texas Instruments invented this graphic programming language, GPL short, not to be mixed up with the GPL license, a typical software license type at the moment. So next to free software, or freeware or shareware or other things, there is a typical license type called GPL, but not to be mixed up. That's simply a language which is part of the console. So it's in the TI-99.4, it's in the TI-99.4a, it's also in the TI-99.8. That was actually never released, and it's even in the TI-99.5, which also never seen the actual market appearance. But in all those, this language and the system was living or was used, and also partially in modules. GPL was used. It was meant to be for internal use only. So it was not meant for every single end customer who buys a TI and wants to do something, start a business, play games, type his business things or whatever. But it was meant for actual real developers who are developing TI software on a professional level. So they needed a GPL software system, which then came in with some documentation for that and how to do that. And actual the GPL code was never intended to be generated on a real TI-99, but on the bigger machines, the mini computers back in the days, not microcomputers, which were the TI-99, for example, and other home computers, but mini computers, which were the bigger ones. We could compare it like now with a computer and server, what you have at home and what you have in a company, maybe. Yeah, I'm drifting away a bit. Yeah, GPL code, part of this big part of the system, and it's actually an inner heart of the system. And some people say you cannot get more efficient than doing things in GPL. Also, it costs less space or less memory, to be exact, than doing things in assembler. But this is not really the topic. The topic is this extended basic and its history. We have the source code. Rich Gilbertson was so kind and typed in every single line of those books, and those are really thick books. And it's not just the actual source code or the binary code which is on the ROM which you could dump, but it's really the source code. So the source code files of the assembly language which define TI Extended Basic. And as we know, TI Extended Basic is very similar to TI Basic, so it's extending it. It's also replacing part of the interpreter which is running when you're using the TI and interacting with devices and all stuff. So it's actually, you could consider it a small operating system, in which you are all the time, unless you change the module. Yeah. So he typed in all the lines, and then the question was, okay, does this make any sense? Would this even assemble and create something similar like what we have in the module as the dump? So would it be compilable? At least I can tell. Richard said, or Rich, I don't know how he wants to be named, said it's matching on the binary level. So the output of the original TI Extended Basic files, he basically digitized in a way, in a very manual way, end up in being the same ROM output and the same GROM output like on the chips. What is the advantage? Why don't I go to the chips directly and dump them with some EEPROM reader or with some with a TI and getting those GROM contents? Well, you have the source code first of all. You have the much more richness. You have command lines. You have command fields on the side from the actual developers of this language. I can show you some examples just to give you a look and feel. Let me try to share the screen. So I hope I didn't screw that up.
Files, but you can do.
Yeah.
No,
So we are here.
you know, you don't have to,
that's one of the files.
right
It's in a very enriched form, visible. So normally assembly language doesn't look that colorful, I know. That's another tool I was developing 2 years back in helping me and others understanding and auto-interpreting in assembly code, but that's also not really the deal now. Let's check the original files. I should have them. This drive original. So basically we have two banks and part of the files are matching and existing in both banks. So their content should be identical. And you see it's not just one file for each bank, but it's actually, and I'm talking only, I will only talk and concentrate now on the assembly part. So on the both ROM chips and not on the GROM chips. Due to some context of interest I had recently, and this will be the second topic I want to talk about. So this is the first ROM bank, and there is a, let's see, can we get the HTML output? Should be doable. HTML creation. It's my original. Okay, that's just a second. So this is a method in assembler language to have multiple source files. And you see here that's actually meant to rerunning on a TI system with disk drives, disk 6 in this case. And having a referring, basically one file is defining, okay, how should it look like? What is the sort order and which files do I want to actually compile in which order? And depending on the order, it will also define in which memory location it wants to assemble it. And that's somehow you could argue this is the summary of the bank 1, and there is a similar looking thing for the bank 2. I didn't try to compile this on a real TI-99 system. What I tried is a tool from Ralf Benzinger from Germany. He's also a TI-99er. He created Python-based tools for doing various things. One of the things, and the tool set is called XTT99. Let me write that in big letters, maybe. So written like that. And it is capable of doing the same thing as the editor assembler and much more. So it can produce from source code files in assembly language. It can produce the actual binary image for a cartridge ROM. It can create the object files, the compressed files, and the AA4, AA5, and AA3 things. All that with all its options. It's command line based, but that's also not really the topic now. What is important is that with minimal adaptations of the code, of the source code, and I'm talking about getting things more defined in a way that this tool from Ralf Benzinger, XTT99, can handle the various things of this environment. So, for example, his tool at the moment, he will improve this, is not capable of these areas are called labels. And if a label is ending or containing a $sign as a character of its label definition name, then his tool is simply saying, hey, I cannot handle it. This is not allowed. And it's actually not allowed on the TI editor assembler, which is meant to be run on the TI-99. So the label definition is alphanumeric, and that's it. And it's 6 digits wide. But Ralf promised to not have this limitation anymore in the next version. So then it means it would be even less changes that are necessary in order that I can perform that now. Let's see. There is XP run1. Do I have here? No, I don't. I don't have a batch file, I think. Not a prepared one. No. Okay. So let's try in real time. I hope you can read that. I'm not sure what the zoom option is in a command window. XAS99, and we want to assemble control 0.asm, and we want a binary out of it with the name fair 1 bin. Okay. What do we have here? I think I'm in the wrong. It should be controls. It's control 0.
Yeah, testing 1, 2, 3.
Okay, sorry.
Testing new
anyway,
microphone.
I'm drifting up. What I want to say is this tool is capable of doing all these lines that was really hard from Rich Gilbertson to type it in. So all this was typed in character for character. And we are talking about this site, not this part. This is generated by the assembly, and also this is generated by the assembly. So we're talking about the right side. But if you're no, not this one. If you're talking about the original, it will not look that fancy. So it's harder to read. But anyway, it's about, he typed it in, edited, basically created text files, maybe even on the TI. I don't remember that. And in the end, all this makes sense and generates the same binaries that are in these chips. So that's the big thing. And I have basically the ability with this tool from Ralph Benzinger to repeat this activity. And so far I only worked on the ROM part. So I'm able to run one single command line and it generates the same binary, and it's identical to any dump I would be able to take from the TI, or I get out the EEPROM or the PROM and read it out with some reader, and then read it. So, or I download the dumps somewhere. It would always be identical, and also this generated output is identical. But what is so much better is that we have basically the ability to read in what was in the mind of the developers when developing these features. So we have these are not from some TI user, but it was from the actual developers. There is partially also, you will see that there is some hint, okay, this got fixed for the TI 99.4 because of a bug found in the 994. So they fixed it in the 994E, or they fixed it, they fixed some things in the system. And since TI extendability is very similar and partially copying and replacing stuff from the system to be done by the module, some functionality of the console, this is basically copied over. So we have, with this, we have the full source code available, and it's actually matching in the end, and we can do something with it, something meaningful. So we could create other ROM files and other GROM files, not hardware-wise, but software-wise, so basically the content for them. But also we have, we had this recent project several years back from a group of people to actually have a module, a homebrew module, which is capable of running any GROM content and any ROM content. So we can create a module that has everything, I don't know, not in English, but in another language, if you want to. Or having another title screen, or having the title in the menu different, or I don't know, the coloring numbers are different sorted, or whatever you want to change and what you extend and want to fix, you're able to do that and actually can verify then the result and make it to something useful. And that's actually what was the starting point for RXB, which is this rich extended basic. So his extensions to extended basic, he made several fixes to it. He extended the functionality and added several calls and subprograms, and enriched the cartridge environment, or the operating system environment as such, by using this. And by analyzing it, by investing time in understanding what is happening. It's a very sophisticated approach to do something like that, but it's more likely to be doable based on actual source code from the developer with their comments and their actual label names. So you will see, okay, what this might be about. Okay, by just reading, okay, I check for the required token, then soon check or soon read required token. So I can read basically what is meant to be happening code-wise, compared to just having a disassembly of the dumps of the ROMs and having to dig through and identifying, okay, is this a code line or is this a data segment that's just used by that code line? So all that is basically not needed, and that's very helpful to understand the machine, to study the machine, and in this case the language, which is a big part of the machine, since it's basically the environment where you work in if you are an extended basic. Yeah. So all this generates in the end a binary image let's see if we find that what I created already. I mean, it will look, there is some object, there is a list that you can create in addition that you usually send from TI extended data to assembler. If you assembled something, you could create a list file or send that to the printer, and then you get a really, really long thing with the analysis of your assembly process. There's a label list in the end, so where which label is defined and can be found in which memory location. And yeah, your source code and basically what it ended up as binary wise. So this jump if equal to scale 12 is somewhere defined here. We'll find it. So it jumps some lines below, and this simply matches the binary information 1306. And the CPU is then actually only reading 1306, and it does exactly know, okay, this is, I need to jump 6 lines below and check, and do this only if it's equal. So if I have in my no, it's complicated. There are some hardware bytes, hardware registers in the CPU, and they are set. All their bits are set depending on a result of some operations from some earlier instructions. So you compare something, and if the output is identical, you have certain bits set in this register, and then you can check for those. And depending on that, you can then either go that route or the other route, or do another check or whatever. So that's how you're working in assembler and on the machine level, because you only have that. But that's just, this is the location where it's actually then stored in the memory. So this would be in the cartridge ROM space, this, which is from 6000 to 7FFF hex code wise, and this is simply in 67632, and this is the line within that file that was assembled. And next to the listing, we have an object that's not very pleasing or helping reading rule. And what is the binary information? This was basically assembled to be binary in the end, and this is now the hexadecimal output. So 2 hex values are generating or defining 1 byte. And since we are talking on a 16-bit CPU, commands are typically 2 to 3 bytes long. Then there is some lines defining data that the commands are triggering. But this is simply the output of what is basically the dump, what would reveal the dump of this. And the good thing, it's matching. So I could change simply 1 line, or I could rewrite the whole string operation things, or I can say, okay, I wanna support different numbers, not always this very expensive, how they're called, radius numbers, the system that is the TI is using, but rather integers, which would be a bit limited, but in most cases, many times faster. For example, here would be the parser, 2 files, and stuff like that. Subprograms, so the call statements and handling all of that is defined here. Yeah, I will try to get one thing done. Let me see how the command is looking here. Maybe we can copy that. That's now. Yeah, now it worked. Okay, now basically we told the tool of Ralph Benzinger, this is the assembler, to treat registered in a certain way. So they are always having an R in between before their register number. Then this is the source code file. And as I said before, this one control source code file defines then this maps pointers to the other files. In this case, it's no longer a disk drive reference, a device reference, but a PC file reference. So within the same directory. This is, I want the list file as well. I want a binary output, and this should be the name of the binary. And as we see, let's see if we match it now. Fair bin and where do we get now the extended basic? Let's see. No, we're not open it. Yeah, you have to trust me that this is basically the same thing that would be in any dumped cartridge in the first bank for extended basic version 1.1. There are two versions of this. There's one version 1, which was able to do recursive calls and had some bugs, and then they fixed. And basically, all of the cartridge you would find are version 1.1, and you can actually check which version you have by this is extended basic. Okay, and we say call version. So that's one of the subprograms, and it should write it to the variable s. And now we just need to write print s, and we will get 1.10. So this is the standard version, which basically everyone has in his machine, unless you have a TI-99/4 or you have with one of the earliest cartridges, or you're a collector and are sure you have both of them because you tested every single one of them and finally found one with 100, or you got it maybe from some employee who knew, okay, this is the very first version, and therefore you have it. It's hardly available anywhere, and basically the better one and the used one is the 110. Yeah. So this is the matching output, and I don't know if you know that. There is another system that is very similar to the TI-99. It's a computer called Tomy Tutor. Tomy is a toy company, I think from Japan originally, and they produced a computer together with Panasonic or Matsushita in the time of the TI-99, and it's considered a clone of it since it's full of TI chips. And we're not talking about just, okay, it also has EEPROMs from the company Texas Instruments, or it has memory chips like many computers had it. But we're talking about the CPU. So it's having a Texas Instruments 16-bit CPU, and it's the TMS 9995. So the same chip, which is in the successor of the 994A, which is in the TI-99/8. It's in the TI-99/2. And it's in this computer also. Could be called console, but it has a keyboard. It's programmable, and the US version of it had an American language-based or making an English-based language, programming language called BASIC. Why I'm telling you this? Okay, what else? The CPU is not the only thing. It also has, and this CPU and our TMS 9900 CPU is so similar. First of all, I think the TMS 9995 can handle all commands and instructions the former one, the TMS 9900 can. So they're compatible. It can read it. It can read any code. And it has 4 instructions in addition, if I'm right. I'm not sure. But there is slightly any difference. I think the database bus is 8-bit instead of 15. or 16-bit. Not sure about these details, but very similar. And it's a TI chip which requires TI assembly language. Next to that, it has a video chip, Texas Instruments TMS 9918, which is the same video chip we have in our TI-99. I think also the 8, the TMS 9918A, which is the advanced version, which is in the 994A, which can handle the bitmap mode, which is the one thing that made Parsec work only on the 994A. And it has a sound chip, the very same sound chip like the TI-99. It has a joystick port with 2 joysticks looking. Let's start an emulator of it. I hope I can do that without too much troubles here. TI. And this is just an emulator. There are the real machines. There was one released in the USA in, I think, 1982. Due to the home computer crash, it didn't last too long. But you will be amazed how the title screen is looking. Looking very, very similar to the title screen of our TI. Also, the version number is similar to the DROM protected version of the system. So remember in 1983, TI released the updated consoles with an updated system, and it calls and welcomes you with version 2.2 in the title screen. And this is version 2.3. And there was a version 3, which was used in the TI-99/8 prototypes. And the TI-99/5, which also a dump was made available, also shows version 2.3. So might be very similar to that system ROM. So next to the fact that it basically can read the same assembly language, the machine basic always felt like, okay, this is similar to TI basic. It welcomes you with ready. Okay, that was happening a lot, but like how it's handled, how files are stored there, how you call devices, how you save and open and do things on a device level is very, very similar and feels a bit copied over from the TI. And today I wanna do basically a proof. I wanna prove that what you're seeing here is actually Texas Instruments operating or a basic language developed by TI developers at Texas Instruments. So this is what you actually see is extended basic. That was exactly the source code files we saw before, a bit modified for different needs. They didn't want to have sprites in there, for example. They didn't want to have a call command, but rather have sound directly. Oh wait, there is not the best respond to my input. But instead of call sound, you just write your sound, or some restrictions they didn't want to include or they didn't want to support. And but yeah, it feels like even when you look at the file or in the memory, or when you store it on I mean, there was only a tape recorder released. There was a disk drive planned for this, but it felt like it's coming from TI, and I will actually prove that this is actually the case. That I can take the source code files that produce these binary images, and now I need to get back out of the emulation and away from sharing my screen to my. So I will prove that the source code files that generate this exact TI extended basic cartridge can be used and adapted in a way that it generates the basic that is living and was sold basically to the people that bought this computer as Tommy Tutor basic. And I think that's a big thing because we never heard of any licensing from Texas Instruments towards Tomy or Matsushita for this machine. So either they stole it, they basically disassembled these chips on the machine, and basically repeated the work hardware-wise, since the motherboard is full of TI chips, and said, okay, we're doing something compatible, a bit different. For example, the memory, the 256 bytes of CPU RAM memory are not in the usual location, which is 8300 to 83FF, but we actually do it at F000, so in another higher memory location. And things like that. But the thing I want to prove is either they got a license and never told about anyone about it. Maybe they got forced to be silent about it because Texas don't want to be known for that they sold this to them, or the market was over because they got out of the home computer market anyway. Or knew that already, and they say, okay, let's sell that sell that license to them to get some money at least. And here you see that it was actually produced from Matsushita, but it got the branding from Tomy. And there was not just this one computer, there was one successor in Japan, with another keyboard, with a mechanical keyboard, very looking like the Coco, if you know that machine. And then there was even a console which was without a keyboard and not a keyboard add-on available for that, which only was able to. There's here a cartridge slot. I'm not sure, I just figured I'm not sharing the screen, so you will not see my mouse. So on the Tommy Tutor, I will get back to sharing my screen. Yeah. So if you go to this big thing, so inside you would see the motherboard. This is the power on switch, and this is the cartridge board. They're looking very similar to our cartridges, and they contain not. What the difference is, they don't contain any GROM chips. So they didn't copy this type of chips. They rather implemented it somehow different, and this is yet to be found out how exactly they did it. So the cartridges. We know that Atari for the TI made this ROM-only cartridges. All these in this different kind of look of the shell are ROM-only cartridges, and therefore, once TI produced this updated 9948 with the updated version of the ROM, those were ignored. They didn't have any GROM present and GROM chip present, and therefore they were not showing up in the title screen. So that was their protection. But the Tommy Tutor was not interested to have the protection since they produced the ROM, the cartridges anyway. The games were actually ported later to the Genève by the community. Not all of them, I think, but part of them. And they're working quite nicely. Maybe the timing is a bit different since the Genève is anyway emulating only the TI-99 inside. But anyway, yeah. It should be doable unless these games would specifically use one of the instructions of the CPU, which are only on that CPU available. And I think we are talking about 3 or 4 instructions. Yeah, so the cartridges were EPROMs or PROMs. I don't know if they were fully burned permanently. And also the console ROMs were without any GROM chips. And that's this riddle which is still to be solved, how they actually managed to get then something like modified extended basic working, which is heavily depending on GPL running from GRAM chips. So this would be interesting to be find out. And that's also one of the reasons I'm interested in learning about this and actually understanding the differences of this. And we basically tried in the last weeks to find similarities in the system ROM of there are two banks in the TomiTutor, and there's one bank for the system ROM, which is the title screen and the console basically that happens. And then there is this basic entry in the menu, like we have the TI basic entry in our menu, which is showing then which is starting the actual cartridge. And if I now look, basically what I started is trying to find similar lines of instructions in both systems, in the TomiTutor basic system and in any of the system ROMs we have available, including one of them was thanks to RxP, the extended basic source code ROMs. And for whatever reason, it was extended basic that was matching in best case. And it's matching much more than you would believe. At the moment, I can compile here freshly. What I do here, let's get into the just need to call the batch file because here I have one, which is storing then this command. So basically check this control 0, and then I added the list because there are no two banks there. There's just a 16K block for whatever we think, and it should generate a list. And I'm talking about this second ROM bank on the system, which is supposed to have this basic, and therefore I'm only interested in generating this second ROM chip at the moment. And I'm generating a bin file and a list. And this is just what I have here on this in this directory. Okay, ignore the back files. Let's delete those. So what we have here as all these ESM are not all of them are used. I kept all of them in. Basically, this is the consolidation of whatever was here or here. And as I said before, the banks are partially having the same files, so we don't need to repeat that. So they only show up here once in the tutor directory. And if I did run this, so I just created freshly this tutor2 bin, and I'm not generating 16 kilobyte here, but 48. So I'm having very many zeros in the beginning until actually where this ROM would start being used. How to do that now? And I hope I can show you now what is. We have somewhere here, we have the original tutor2, also with this offset of the first 8 kilobyte. No, should be basically from the beginning till 7 FFF. It should have only zeros, and then it starts with this ROM chip. And we check our tutor output here, and we want to have the tutor bin. So I'm comparing an actual dump of the ROM chip against what I just created, and as you see, it's not. This is how fast you compile 16 kilobytes and a whole list, which would take probably minutes on a TI-99 to assemble every single time you would do a single byte change or character change or add a comment or whatever. And I'm comparing these two files now on a binary level. I hope this works out nicely. In this resolution, I lowered my screen resolution to not have such a high resolution for recording. Doesn't look too bad. So basically the bank starts from 8,000 till BFFFF. And the left side, you see here on the left side, you see, oops, I didn't want to do that. I didn't want to change it. You see the actual dump chip, the content of the dump chip. And on the right side, you see the compiled output of the Texas Instruments extended basic source code files, a bit adapted to produce the code for a different memory location, because it doesn't have the cartridge space at the same area where TI has it, and it doesn't need to have two banks and all this. So each of the source code files, I try to identify where it should be placed, and then also they are linking to each other, either with absolute addresses, which is not so good because I need to adapt those if they are pointing. But most of this in extended basic was anyway referenced and connected via these label references. So you say you want to jump to whatever is wherever this label is defined, and if the label is defined in Tomitu to somewhere else, then this jump address will still be the correct one and adapted automatically. The only thing I need to do is change where the Tomituto is actually generating these files. And you could compare here this output. So first of all, the sort order is a bit different, and the location to which it renders this information. This is just a comment, but it also has this information to render and compile and generate the assembly for this memory location. And you see here that basically covers almost all of the bank. And the output is here. Oh no, here. Uh-oh. The output is here, and it starts with, I think here 9000. Yeah. The zooming is not too good to have it exactly the match, but this is basically, it starts at 8, but I didn't decode yet anything from 800 to 80 to the end of this 2 kilobytes. The first thing I found was here 9050. So, and this was, I think, what was it? XML 035 059. It's a long day. That's the code name for TI extended basic at Texas Instruments. All the internal documents from them are naming that product product 359. Therefore, this is in part of even naming some of their source code files. So here you see mathematical functions, I think, and ref, and all this. So it reflects somehow. And if we go back, basically this is the first thing, which is the thing that can change or have a difference. Here is, at the moment, I'm not generating anything, therefore it stays with zeros. And here's the first thing I actually have content in. And to explain the colors on the left side, it compares the left side and the right side, and basically the same location, memory location, or in the binary at the same spot, it expects to have the same byte value or hexadecimal value in both places, and then it's having it white colored or not colored, and it's marking anything that's different. So here we have zeros because I don't have anything defined here in Extended Basic yet, because I didn't find the matching things, and therefore it's saying, okay, here it's, for example, BF36, BC98, BB2C. Probably these are jump addresses to beginning of subprograms or beginning of routines, which I didn't find yet, and therefore I didn't have these references in the list yet. But as you see, besides that, yeah, this thing, which is 820 bytes, is matching absolutely the same from beginning to the end. And we're talking about, I'm generating from Extended Basic source code files the Tommy-Tutor basic ROM, or the Tommy-Tutor, not basic ROM. Yeah, it's basic ROM, but it's the basic system. That is basically the system, this green thing that we saw before and was handling my print and code line statements and whatever. So this is the proof basically that this comes. This is not just imitated and it was looked at maybe, and then, okay, we will also do this like that. But they actually had the source code, not the source code necessarily, but they had the code, the assembly code, be it the source code by having the proper license, or maybe they had ability to get to the source code somehow. I don't know that. I don't know how properly protected Texas Instruments networks were back then. Or they had at least the ability to dump these ROMs from Extended Basic from the cartridge and get basically a disassembly output. So basically trying to create the source code lines without any comments, without anything that would help you understanding it, and simply a lot of mathematical things to do to get back to what probably would be a source code file. But that's not so important. But what is important is I can generate the exact ROM for most of the parts of the chip, and that's not just the only thing where, oops, I edited something now, where we have a full match of 800 follow-up bytes. This is the next page from 9.3 to 9.8. So here you have two words, a bit different still, because I'm not fully done yet. I was a bit sick this week. I would like to have finished it already and would show more, but this is the current state, and it's like what it is. This is the next page. This is a perfect match, and we were talking again about 1,140 bytes matching of 16 kilobytes in total. What this module defines. I'm sorry, I edited something again. I should open this in write protected mode. Next page, again, here's just a slight difference still. I didn't fully work on all the source code files yet, and what is yet to be shown is what was actually changed. What did you change, Klaus, to not generate the Extended Basic ROM, but generate this ROM and so exact almost, except for some spaces which are still not all handled. So some parts where I needed to adapt the length of the generated code of an individual file to match the Tommy-Tutor known length, and I then replaced some non-matching things with zeros a bit. But that's just cheating for now. And some parts are I didn't find any source code yet. Maybe it's not from Extended Basic. So it could be that these 72 bytes were really coming, and some developer at Matsushita said, okay, I need an assembly routine and I will put it in there, and it's not originating from Texas. Or I didn't find it yet. As you know, that Extended Basic is highly depending on GROM, and therefore also needs to activate the chips to read the things from it, to get the GPL information, and is doing that as part of its interpretation of the TI Basic. This is not necessary like that on the Tomituto. There is no GROM chips. There's probably this information on within the system ROM, but simply read differently without any GROM involvement, and this needs then to be adapted. So this was part of the adaptions. And what I also found here, again, it's a whole page is completely identical already. Next page is also completely identical. And then we have here again some inconsistencies. At the moment, it's not like that the extended basic cannot be modified in a way that it generates the identical output. This can still be the case, but it could also be that that we are talking about unique content that was simply developed by Matsushita for that purpose. Or even they were contracted by Texas Instruments to produce it for them and they adapted it. I don't know that. Whoever has information on that, I would be highly interested to learn about that or to see actually a service contract about or a license contract. And here we, I think, end up in, again, some space where I don't have any source code. A big chunk of source code was not used, which was the subprograms. Subprograms. This is, as you see, 10 and 23 kilobyte. That's with comments, of course, but comparing it to the others, it's indicating it's a very big file. And alone on the, I think it's at least 500 bytes compiled. So I didn't find it anywhere in the tutor ROM yet. Maybe I looked at the wrong bytes yet. They're cheating a lot whenever there is this GROM activity needed. They're then simply inserting some statements which doesn't make too much sense. So compare this register against its own, or basically a null operation, and some similar things. I can show you that. That's the next bank. And here we basically end up having any code left. So from B900 to BF, except these last 2 bytes, I don't have any matching source code files. But we are talking roughly from this 8 to BFFF, which is should be 16 kilobyte, since the ROM bank is, or the ROM chip is 16 kilobyte. We have roughly 70 to 80% correct output already. And I did not add some disassembled list files from the Tomituto to that. It's the whole thing. And we can compare them on an individual level. Obviously, this control file, which defines the list, is heavily modified if you compare those two. The listing changed. Some things are not needed or not. I didn't find them. One I told before, it was a subprogram, but then there are also these little things like GROM read, GROM writes, and GV writes, and they all are for mainly ERAM feature. It's named in the extended basic source code, and ERAM feature probably stands for extended RAM, which is the external RAM. So this memory expansions on the sidecar or in the PEP. And whenever I saw these lines, I had to remove them to be matching again for the Tomituto. So these are lines which are typically removed. Let's see. This is the first. Which one we pick? I would like to see a good one. CPT. Let's take CPT. The character property table. See, you would have no idea what this is unless you have the ability to read the actual source code. And as you see, what I changed is where it should generate this content, so which memory location it should start, and from there, most of the code is relative, pointing to lower or upper addresses. but always in the same range. Yeah. These are byte changes, byte definitions, and they are all identical. There is no single change. All here is white. White indicating there is no change. Red or yellow indicates a change. Red is the current line I'm investigating, and yellow's lines are other lines in the file which are changing. And what I needed to do here is basically repeating or imitating I'm a TI-99A 4 and not a 4A, because the 4 only has uppercase characters and not lowercase, and this was added for lowercase characters. And this shows I don't need that. Otherwise the output is too long, and therefore I needed to just comment them. Start making a star in the beginning is adding a comment. And the other change was where I want to compile that. And all the others, these are generating data files which are identical. And what we see is basically 6. That's the memory location in Extended Basic, and that's the memory location in Tutor. And if we go to our comparison, it should be what, 9136. And I think I have that covered fully. So it's a bit different. 9136, so somewhere here. So all these 20 are these bytes for the alphanumeric characters. But these are exactly like that in the same repeated steps. So it's not like a coincidence or so, but this was copied over. This was taken to be basically matching that functionality. And that also explains why people said, okay, Tutor has the same tokens in the background or when storing a program in memory. And even tokens from the TI work on the Tomi even though they're not in their manual, because they're in the system, because they copied it. And that's the interesting part. So we basically have the ability to see now what Tomi did. We can improve that. So if we find a bug or say, okay, we want sprites in there, we can try to get it in there working, because all we need to do is basically burn some EEPROMs and replace the regional chips and have the advanced feature. And even the Tomi Tutor has this feature that in case you could basically overlap or overwrite the current system ROM, the memory from the system, by having something coming from the cartridge. So the cartridge bus can deliver and define the system ROM. So we could just make a cartridge with an updated ROM and can say, okay, now this would totally be compatible with TI-99 basic programs or whatever we want to do, or this adds HexBus interface, device driver or whatever. And this is, okay, that's an easy example. There was hardly any change needed. Let's see another one. CIFS, for example. What is that? Convert integer in floating. Floating numbers, that's the name of these things. And as you see, right, the left side is the extended basic ROM 1. And it's also included in the second bank, but that's the source code from Texas Instruments engineers or software developers. And that's what that's the right side is basically generating the same binary, which is matching and ending up in the ROM in the Tomi Tutor. So it would be really nice to know, was this licensed somehow, or was this done for them by Texas Instruments in some secret project, or was this stolen? So this would be really nice to find out for history reasons. And what it also gives us, you can see actually for the first time nicely the source code of the Tomi Tutor without having to disassemble it and then guess about how this label would be called, if it's called from there. it would just have the label name as the address, and I would not have any idea that this 01 and the developers intended that in this line it should add 1 to the exponent for the divide. So it's so much more easy, especially for assembly language, to read and understand what might be happening at this line, or what is the intention of the developers. Also, as you see in this file, the only change was actually where it should generate the code, but the code itself is the same. So all the lines, which register are used, where are they called, where are they moved from or cleared or whatever, exactly the same. And it produces the Tomituto ROM, basic ROM. It's not always that fancy looking. Let's check for next. Basically, always I had to adapt where it's generating the memory. Here, for example, I had to rename this label because it was used another time, and this was not happening for the TI extended basic because of this 2-bank split and was not affecting the other bank. But here I am doing just one with both banks, and therefore I have this, I had to rename simply the label. And whenever the label was referenced, which was not a lot, just in this file, I had to rename the reference name. Here is, for example, one thing. Left side, again, extended basic. Right side, Tomituto. I had to comment out this line. I had to remove it. It's not ending up in the binary. And then the code matches. So let's check the for next. R140. It's a bit later. R140 starts here. And you see it's all white. And I think the for next is not that long. Let's get back. The for next is for these 4 statements, so you can have this for loops and stuff like that. And as it's, you have really nice documentation of the things, like it was in the original source code files that generated these files at Texas Instruments. And let's see what has changed. Here I removed this one line. This is just showing as different because I named the label different because of this conflict. Here, there were 2 lines in extended basic which did show up, and because of this, the length when I compiled it with them was a bit too long, and then I had to find, okay, where is the difference, where I should comment something out, and then this is basically the work I was doing lately to find basically what is actually needed to be changed in the source code in order to generate the same output. I hope this gets clear. And whenever I had to do a change, I mark this change here. You see the line again here lowly with a TOMI statement at the end, at the very right thing, to basically have an indicator. On a normal screen, this would all show nicely. So you would see immediately that this line just changed, be it removed, be it commented out. And basically, whenever I removed something, I just commented it and kept it. So basically, it's part of the original documentation of the source code. And it's clear that this got removed just for this console. Here again is just this label rename. Here again, yeah, that's a nice thing. So left side is extended basic. The commented out something. Check is added in sym at 81 in May, and I think that's jump if lower than, and then it jumps to this address, which is probably somewhere lower or upper in the close range. And TOMI enabled this, indicating, I would say, either they had a different version of the ROM, maybe they worked on extended basic 1, or this part originated from also the TI system ROM and not just from extended basic, where this was included. But how would otherwise they get this line enabled? Basically, how would they know if this was never in the output that was available to purchase in the dump? It was not there. How would they know that they need to add this line? So this is also sometimes there are some bug fixes documented in the extended basic, and sometimes I need to just uncomment it and make it like it would be for the 994 only, like this, removing this lowercase support or removing this ERAM support. Here's one of the few examples where an external RAM is still in there and actually part of the binary output. Maybe it didn't hurt or so. I don't know. I didn't fully understand the code yet. I was more on the task lately to get it basically binary matching, and which lines to deactivate or change or add or replace by other lines. And here again, these 2, 4, 6, 8, 9 lines, I had to comment out. And whatever, the only thing I left from these 9 lines was this label to have basically a jumper to this line, like for a go-to statement on assembly language. But the other lines are commented out, and then the code is nicely like in the binary on the TOMI. Here again, there is some line commented, which is for external RAM. And here again, one line commented. So most of the times, I don't know how to say it, TOMI did, or how they did it, is commenting out, removing stuff that they think don't need it, or they are sure they don't need it. Basically, they didn't need this wait states for the GROM to react, for GROM chips to react, so maybe they removed those. They didn't have this ERAM support, so they dropped that. So probably if we would ever have a memory expansion for this computer, for this TOMI tutor, we would not have awareness of that or full support from the basic, at least in this current state. We could change that because we have the source code now. So we could extend it and also re-include subprograms or any commands or tokens we are missing. And for example, I think there is nothing to start anything in the assembly direction to allow basically the user from basic to run any assembly code lines. I think there is something for to get some stuff into the VTP RAM and enable then some sprites, but that's about it. Here is some think that the actual label that was jumped to was removed here, and therefore it jumps to the next line because it's then the line they wanted to jump to, and therefore I replaced it here. And this is again the rename of the label. But that's all it needed to get a binary matching output for the whole file. It's not always that nice. Let's check this one. Some are also work in progress. So here, for example, I see I didn't look up. I just knew, okay, the binary on the left side had a data statement with 1303 as the byte value. Yes, the hexadecimal value. And if I add that, then the length of the generated file is matching, and therefore the code lines which are here and are identical are then at the light location, and therefore it shows here not as yellow but as white. If I'm off in the generated output in this comparison tool by just 1 byte or 2 bytes, so if I have the same sequence D208 blah blah blah, like on the left side, but at a different spot, like here, starting here or in the next line, it would show that as yellow. So it's not that clever that it can or finds matching strings or matching lines of things, but says, okay, like mastermind, I found it, it's similar, but it's at the wrong spot. It's not that clever. But for the purpose now, it was quite sufficient to get to this level already. And here, this is still work in progress, it seems, this file. So here I then got off from the length somehow, and therefore I said, okay, even though I'm whatever here, I want to start at this location because I knew from here these code lines are also in the binary in the Tomi tutor. So I will probably have some inconsistencies in this area, and I didn't get to that yet. Also, this data statement is not nice, so probably is one logical sense-making code line. But that's the thing that we would have all the time if you just work back from a ROM dump towards disassembly towards assembly source code. I have that somewhere, and I got that. And there are some tools to generate that, but they are dependent on your input partially, where this basically assembly code should have been executed. So where is that now? Here, that's the disassembly output, and this is done by a tool, yeah, to generate from a ROM dump a potential assembly source code. So it assumes, okay, this is TI-99 assembler code that is in that chip, in that ROM dump, and it tries to identify code lines and data statements next to it. And sometimes it's matching, sometimes it's off because some, as you see, some lines take 1 byte, some lines take 2 bytes, and some lines take 3 bytes. And sometimes you have, and shall have, data lines in between, data statements, which should then actually make the command start there, and then it means something else for the CPU. So it's very hard to get something useful from there without any big analysis. So this is why the other way, getting from extended basic source code towards the ROM would be so helpful, because you then have a real nice commented source code with nice labels, nice variables names, and everything what should be a data statement, and only that is a data statement then in this source code and not anything else. So this is work in progress. I'm cheating there, for example, here also. That's not a cheat, but that's a change, because the memory of some stuff is simply at another location. That might be the VDP RAM, I'm not sure. So this is work in progress, and that's why it's 75 or 80% at the moment. But I'm trying to get one file after another and get it mostly nice and green, and green would be white. Here is parse, basic parse code. So it's used by the GPL interpreter, and it defines several variables and some data statements. And here you see I had to extend some data statements, which I was sure, okay, those are data statements, because they're also referenced by some code lines then, and therefore I added a Tomi label 1. I don't know what the purpose of the label is yet, so that would then be a community attempt to give that a proper name, or analyze what is the meaning and then give it a name, and comment it with some comments that we think make sense. But that needs only to be done basically for things that got really added by the Tomi side, and not just things got removed or replaced, not commented out, or uncommented from the source code or from the TI. Yeah. Also, here is some. Sometimes the line is not necessary, but there's a label to it. So basically, other lines jump to that line. So I need the label, but I don't need. Or actually, this is something else. Actually, it adds a line on the Tomi side here, and then I need to move the label to the former line, because this move register 11 to register 13 is actually happening a lot on cold uncalled functions or something. That this is happening first, so probably it stores some things in the R13 to save it, and then after return they get the original value back to have it not lost. Also, this limit this is all removed, or not removed, commented out in order to have the same length. And on the Tomy only this showed, but this is also work in progress. These lines probably will have a meaning sorry, that was the wrong one, in the output. Let's see, to list, find the address quickly. So F0, now that's binary output, it's not a line. Okay, that's a jump actually into the CPU RAM, which is a bit on another line. Yeah. But this would jump towards another line in the same thing. Here there's one added. Here again we have this, but you see there's hardly any change. They didn't completely override everything, but they took what was there from extended basic and adapted it to the needs of this console. So here, ERAM, which is this extended RAM, not needed. And again, most of the stuff is simply removing and commenting out lines. And this is the other example, adding in this, I don't know, is it a swap? Swap bytes? I don't know that. Of R14. And this is simply added a lot. Sometimes also 4 times in a row. I think to not have to recalculate all the absolute addresses or so for them. I don't know how they did it, but this is one of the most happened item adds or item adds on the Tomy side I saw so far. Other than that, it's mostly commenting out things to have the reduced code set that we actually have in the ROM. Yeah, that was parsed. There was like a lot of changes, and I'm not fully through with that yet. Scans. Scan is the main looping structure of the pre-scan routine. And you see here some added features. And it was not initially there, so it was added in the extended basic source code at one later point in 81. And here is one slight change, you could say. So first of all, they don't move the 1 byte only, but both bytes. And again, this is a copy, a move statement. And here there's this plus added for the second move statement. But for example, save GROM address they kept. Maybe they removed it in the function that is actually called here. But most of the times there's minimal changes. And partially, sometimes it looks a bit ugly, but this is actually only commenting out lines and not a single change other than that. That's just, okay, I need to remove those lines to have the same length on the right side. Okay, yeah, I think you get the picture. It will not change. I will not go through all of them now. And yeah, here again, some byte definitions simply are not supported, so they are not there and therefore need to be commented out. Otherwise, the length is not matching. Yeah, so I hope to have sorry about that. So I hope to have a fully binary matching output soon. and I will try to get to those 100%, and we'll try to resolve the issues. Sometimes I very similar looking code lines are coming in a row, and then I maybe mark the wrong one out, and actually the proper one they kept was the other one, and then because all are relatively linking to each other, this memory looks the memory output looks completely different if it's generated for the address 7000 or 7004. Then it all is 4 bytes higher in many of the bytes, and nevertheless finding the matching things is not always easy, but it looks once it looks more simple, it's often more correct. So I hope to have a 100% matching thing, and we'll also find some solution about the gaps. One gap was this header information, probably for the system. This first 42 bytes, I think, or 41 bytes, and then there might be TOMI specific code, or code that is coming actually originating from the system ROM from TI and not from extended BASIC. So maybe we'll still find something in the future, but that is the current status for now, and I'm already very happy about it, because it already proves, okay, 80% are actually coming from the Texas Instruments lab or software developers, and not from any TOMI tutor developers, which repeated the functionality, but they actually copied or used the functionality that was there at TI and invented there. And yeah, this looks like it could be very useful for the future, in combining these machines and sharing software and hardware solutions for that. So maybe we get some loader for assembly working, so we could work on that machine as well, and have more use of that besides just being in a basic interpreter and having to run basic and currently storing only to cassette tape or emulated cassette tape, and get that back. Yeah, that was it. Yeah, like that, we'd have no ability for questions, but I would be available for questions on Atari Age. I'm the user KL99 there, KL99 for Klaus Lukaszek 99. And there is recently got the Atari Age got a new subforum for computers that have Texas Instruments chips, but are not the 994 or not 994A. So that would fit the 998, the 992, the 995, the CC40, the CC40 Plus, the TI 990, so the mini computers, the big ones, and things like the TOMI tutor and its Japanese versions of it. Yeah, I think that's it. You can also reach out to me on mail. I'm reachable with klaus.lukaszek@ti99.eu, like Europe. And yeah, I'm happy to get in touch with you. And I would really like to hear anyone knowing about anything internally about the TOMI, how this really happened. Was it stolen? Was it licensed? Or was it actually done at TI for them? Whatever. Yeah, thanks a lot. How this really happened? Was it stolen? Was it licensed? Or was it actually done at TI for them?
Well, it was very interesting. I didn't understand everything, but I certainly enjoyed learning about that as much as I understood. Um, Vic, are you ready to do any other presenting, or what? What are we doing? Very interesting. I didn't understand everything, but I certainly enjoyed learning about that as much as I understood. I I just noticed that we have a time delay. I'm watching this on the big screen TV so that I can read everything, and uh, it's a lot easier than trying to do it on the little iPad screen. Vic, do now.
Yeah, I'm ready for another display. I'm just vexed with a handheld microphones I can't hold in my hand. Audio connections don't connect audio. Webcams don't. But yes, I have my next program queued up and ready to roll at any time.
Okay. We
So this will
waiting.
be
And
the songs from South Pacific.
okay,
Yeah,
I believe we some other videos that we could.
You're muted now, Hal.
Say again. At any rate, I think that perhaps this show may be going a little long for some of our viewers.
Let me close this one tab for YouTube.
Okay.
Yeah.
We have those.
Well, another joke here. This is the songs from South Pacific.
Okay.
Yeah, this uses the TI Sings Play from TrioSoft software. And it looks like this was programmed by Harold Timmons. So here we will have the TI sing Some Enchanted Evening with animations. Okay, that's not what I was expecting. Maybe I'm thinking of another disc where they had the two faces facing each other, and they were actually singing the song with voices too. Let's load up another fun thing here. We'll go to the Finalgram, go to letter Q for tools, section 2 for letter D, terminal emulator 2. Okay, we'll quit that. Go to basic. Okay, have to be careful I spell it in right. Loading from the Nano. Initializing. and we'll run it.
For and 7 years ago, our founders brought forth on this continent a new nation, conceived in liberty and dedicated to the proposition that all men are created equal. Now, we are engaged in a great civil war, testing whether that nation or any nation so conceived and so dedicated can long endure. We are met on a great battlefield of that war. We have come to dedicate a portion of that field as a final resting place for those who here gave their lives that that nation might live. It is altogether fitting and proper that we should do this, but in a larger sense, we cannot dedicate, we cannot consecrate, we cannot hallow this ground. The brave men, living and dead, who struggled here, have consecrated it far above our poor power to add or detract. The world will little note nor long remember what we say here, but it can never forget what they did here. It is for us, the living, rather, to be dedicated here to the unfinished work which they, who fought here, have thus far so nobly advanced. It is rather for us to be here dedicated to the great task remaining before us, that from these honored dead we take increased devotion to that cause for which they gave the last full measure of devotion, that we here highly resolve that these dead shall not have died in vain, that this nation, under God, shall have a new birth of freedom, and that government of the people, by the people, for the people, shall not perish from the earth.
And with those inspirational words from President Lincoln, just as pertinent today as they were when he first wrote them. And that's it from this end. Hal?
Okay, well, thank you, Vic. I guess that we have decided to save some of those videos for a later program, probably for our December program. And before we leave, of course, we want to thank our presenters by video, Ronald Van Klein and Klaus Lukaszek. And Klaus, if you're, I can't see the YouTube chat, unfortunately, because I'm watching YouTube on the big television screen. It doesn't have the chat feature. But if you're there, to answer any questions that people might have, you can certainly do so in the comments section or in the chat section as long as we're on the air. Jim, did you have something planned for a post-meeting get together or?
I don't really have anything planned for post-meeting. So I guess if we want to wrap it up soon, we can do that. And then probably John and I will powwow after for a little bit.
Okay. Well, looks like we've gone to a black screen here on YouTube.
Okay, I can wrap it up then.
Okay, then I guess that we have to wish everyone a happy Thanksgiving.
Yeah, I can see what shortcomings I got on this end. I'll do my best to straighten it out by next month.
Okay. Everybody, we wish you a happy Thanksgiving if you're in this country. If you're in a different country, we hope that you're staying safe and that everyone is maintaining social distance, wearing masks, staying away from germs, as my 6-year-old granddaughter wrote me, said, Opa, please don't get the germs. And I thought that was a very appropriate sentiment. I'm trying very desperately not to get any germs, especially not COVID-19. At any rate, I think that that'll do it for this month. And hopefully we'll see everybody in December. So bye from me.
Yeah, so what day in December would that be? Looking at calendar here.
Usually it's our the first Saturday in December.
The first month in December, first weekend. Oh, December 5th.
December 5th. Okay. I'm
Yeah.
looking at a November catalog.
December 5th. We ought to be clear for that.
December. Okay. Well, thanks everybody. I think we had a pretty good meeting. And
yeah. Sure.